In this video, we'll show you step by step how to build a hydrogen generator in your garage. Hydrogen is a highly energetic gas that can even melt metals. Stay to the end of the video and you will find out how you can get hydrogen and how to use it. Warning, handling this type of gas can be very dangerous. It should only be done under strict safety conditions. To begin, we'll use this 1.3-liter airtight glass container. Remove the accessories attached to the wooden lid. We'll use these 40mm diameter stainless steel washers. Place them on the wooden lid and mark the points where you'll drill. Mark another point in the center. Drill these 3 holes with a 5mm diameter drill bit. Countersink the holes at the ends. Then tap the 2 holes with an M6 tap. You'll find links to all the materials used in the video description. This is how the threaded holes will look. Now we'll cut 2 M6 stainless steel threaded rods. We'll use this rotary multi-tool to cut them, but you can use a handsaw. The 2 threaded rods are the same length. We'll remove the burrs from the ends. Be careful when using these tools. Now we'll use this small piece of acrylic, and we'll mark the position of the holes at the ends. We'll drill 2 6mm diameter holes. There we have it. Now we'll need the rest of the washers, a total of 66 washers. We'll also need these M6 stainless steel nuts, 3mm wide. To begin assembling the electrolyzer, we'll put a nut on one end of each rod. Next, we'll place the acrylic piece, which will serve as a spacer between the 2 threaded rods, and we'll secure it with another nut at the end. Now we put a washer on the rod, a nut. We tighten each nut we add. We add another washer and another nut. And we'll repeat this washer-nut-washer pattern until the rod is half washed. This is how the first rod will look, and we repeat the process with the second rod. Now we need to drill the center hole with an 11mm diameter drill bit. And we'll tap this hole with a 1/4 inch tap. We'll need 4 1/4 inch dowels for 6mm tubing and 1/8 inch fitting for 8mm tubing. We put the sealing gasket back on the container lid, and on both rods we put an electrolyzer height adjustment nut. We screw the first rod into one of the outer holes. And then we screw in the second rod. Now we loosen the first rod slightly so it fits into the hole in the acrylic spacer, and we secure it with another nut. This spacer will prevent electrical contact between the 2 rods and their washers. We apply some silicone before tightening the nuts to perfectly seal each hole and prevent gas leaks. We also apply silicone to the top and add 2 washers and 2 nuts. In the threaded hole in the center, we'll place the 1/4-inch dowel we showed earlier. We replace the lid's locking mechanism and insert the 2 rods with the lid into the container. The hydrogen generator tank is now ready. Now we're going to make a safety device called a bubbler. We'll place 2 1/4-inch dowels in the lid. We mark, drill, and tap them with 1/4-inch threads. Next, we'll tap the inside of one of the dowels with an 1/8-inch thread. This way, we can attach the fitting to the dowel. Now we can attach both spigots to the lid. We'll fit the 1/8-inch fitting onto the threaded spigot. We'll add a bit of Teflon tape to prevent any gas leaks. This is how it looks once attached. Now we remove the nut because we're going to attach this piece of 8mm diameter tubing. And with that, we'll have finished the bubbler container. Let's make a second safety element called a flame arrestor. For this, we need 2 32mm diameter PVC caps. We'll drill a 1/4-inch threaded hole in each of them. We'll attach a spigot to each cap. We need this PVC pipe, 32mm in diameter and 150mm long. And this 70-micron stainless steel mesh. We took it from a water filter. We'll mark 4 circles using the PVC pipe and cut them out with scissors. Insert one of them into each cap. Set the other 2 aside to insert into the PVC pipe. Make 2 equidistant marks on the PVC pipe. We'll use PVC adhesive to glue a cap to one end of the pipe. We'll wear gloves to handle the following materials. We'll need 2 parts crushed glass and 1 part fine sand to fill the pipe. It's advisable to wear a mask and safety glasses, since glass dust is very harmful. We add a first layer of crushed glass up to the first line we marked. With a few gentle taps, the glass will settle to the bottom, reducing the gaps. Now we place another of the stainless steel mesh we cut, and we compact the glass in the mesh using a rod. Now we fill the tube up to the second mark with sand. We add the last steel mesh and compact it again. And finally, we fill the last layer again with crushed glass. We'll attach the second plug with PVC adhesive. This device will prevent the flame from traveling back to the bubbler tank, thus preventing any type of deflagration. We will need a 10 amp circuit breaker like this one. We have made a small bracket to hold the breaker. The breaker snaps into the hole. We will also use a safety fuse in the cable that connects the battery and the breaker. We connect one end of the cable with the fuse to the switch and another cable that will connect from the switch to the electrolyzer. Here we have a small 12-volt battery which will power the system. We add a little hot glue to secure the bracket with the switch. We attach the positive wire to one of the electrolyzer's rods with a nut. And we connect the negative wire to the other electrode. We must tighten the nut securely to prevent a loose connection that could overheat the wires. Now we connect the positive and negative wires to the battery. Using a 6mm diameter silicone tube, we connect the outlet of the hydrogen generator tank to the inlet of the water bubbler tank. We secure the tubes with cable ties. The bubbler inlet is the one with the fitting to the tube inside the container. This way, the hydrogen will flow through the tube to the bottom of the tank, which will be filled with water. Using another silicone tube, connect the bubbler outlet to one end of the flame arrestor. The flame arrestor is designed to capture any potential deflagration, but if it fails, the gas can ignite inside the bubbler tank, thus protecting the electrolyzer. This hypodermic needle attached to a silicone tube will serve as a torch. Connect it directly to the flame arrestor outlet. Like the other silicone tubes, secure it with a clamp. We're going to fill the tanks with water. But first, in the electrolyzer tank, we'll add a little potassium hydroxide, commonly known as drain cleaner. 2 or 3 tablespoons will be enough. Fill both tanks, always leaving a small amount of air unfilled. Stir the water well to dissolve the potassium hydroxide salts. And close both tanks. The potassium hydroxide dissolved in the water helps increase its electrical conductivity, thus facilitating the electrolysis of the water. Close the tank and begin the tests. When the switch is flipped, direct current flows from the battery to the electrolyzer electrodes. This current passes through the water molecules thanks to the large conductive surface of the washers. Water containing dissolved salts begins to conduct electricity, and its molecules break down into their basic elements, oxygen and hydrogen. We're going to create hydrogen bubbles which will ignite with a gas torch. Even the bubbles are capable of generating a small explosion. Imagine what a huge amount of hydrogen could do. If we apply a flame to the needle's outlet, we'll have a small torch. The flame is small, but very, very powerful. This flame can reach a temperature of 2,800 degrees Celsius. It's an incredibly hot flame. Let's see how it behaves with another material. We can even melt the aluminum of a soda can. The flame has traveled back down the tube and has been stopped by the flame arrestor. If it weren't for this, the flame would have reached the bubbler and the explosion would have been dangerous. We can see how the flame has pierced the metal. Of course, tin poses no problem for this powerful flame. Let's fill this bottle with oxyhydrogen gas. That's the gas our electrolyzer expels. When we insert the silicone tube into the bottle, the pressure forces the water out, leaving only gas inside. For safety, we'll move to an open area to do this test. The first explosion destroyed the bottle. The second explosion had the same effect. But the third time's the charm. Thanks for watching. If you want to support our videos, you can become a member and subscribe to our channel. See you for the next invention.